Hello everyone, welcome back to my channel. So today we're talking about the planetary motions. So if we want to talking about planetary motion, actually we got to use we got to use the scientific method to help us to understand the planetary motion. So what is the science? The science before the original of the science actually is really there's a hard road for over to learning about the ideologies. So actually, when we back to the in the middle when we back to the middle age in the Europe, lots of people propose some interesting ideas about what is the universe and what is the stars. There's lots of the stars in the galaxies, and also there's a moon, there's a sun, and what this object can circle around. So maybe the motion of these objects in this out of the earth. So this idea is really important. So how can we use the science to help us to understand the whole stories about emotions? So when we're starting to talking about planet motion, we not just focus on the planet, we focus on the whole universe, and we use this when we want to talking about a universe. We use the mechanic. We want to know the mechanisms of the motions. So this is a really important topics. Okay, so first of all, so we got to back to the in the origin, talking about the origin of the science. When actually in the AD 24th, 27th, there's a man who called the Ptolemies, and the Ptolemies proposed an idea that this is the geocentrism. So what is the geocentrism? It means that when in the past that they say that the Earth is the center of the whole in the universe. So everything is just circle around the Earth. So this idea is that not just this ones. Um, this is maybe the sun, and also that in the sun there's a lot of light years and years there may be just like this one. Okay, so this may be some like the menace, or maybe there's lots of all of things will circle around the earth. So everything, the earth is everything, and the earth is the center of the universe. So so we call this, will call this series will be the geocentrism. In the Chinese is the 地心说. So the earth is everything, because that so for some religious parties, they in the past that they want to prove that this is true. So they use this idea to prove that this is the right the theories. Okay, so because they think that the God will create the world, and also the world is the most beautiful in the earth is the most beautiful in the universe, and they don't think that the earth is the unique. Until now that we think that actually the earth is not unique enough, because there's a thousands and billions, there's thousands, billions, trillions stars in the universe we have already observed, right? So this is the Ptolemaics, the Ptolemaic theory about the geocentrism, and we know that because in the past, the scientists actually they observe the stars, they observe the planetary using the eyes, so they have very sharp, and really high resolution eyes to observe all the things in the skies. Okay, so this idea is really important. So when we back to this idea, and so this theory actually who follows can be generalized. So all the things that I think this is truth, and when we go back about in there's a lot the 1,030 ago, about the 80s, a man who called Copernicus. And Copernicus, he proposed an idea that it is a heliocentrism. And in Chinese, it's a 天动说, or maybe the 日心说. Okay, so it means that everything will circle around the suns. Okay, so actually the sun is a bright and very bright. Is a big and bright and very shining in the sky, right? So he is the most important object in our universe. So everything will circle around the suns in these ideas. That, however, these ideas is not really accepted in the past because that in scientific views, because lots of people think that there's not the heliocentrism doesn't have enough. It needs more. It need more data. Okay, so because it doesn't have need more data, but they didn't have the more data to prove that this is right. However, that you will find these years. This is 27 years after this is 27th, and this is 20 here is 30 hundreds years ago. So this you will find that all he had already passed over past 1,000 years ago. So he was be thought that he doesn't have no data. However, that because all the data he just want to prove this the geocentrism. Okay, so this is the background of the planetary motion. So lots of people he find out that they think that the geocentrism actually not elegant enough to prove that all the things is elegant. However, the scientists and also the philosophy thinks that all the things have to be elegant enough. So the Copernicus proposed this idea. However, that this theory is just a theory because they didn't have enough data to prove that. Okay, so when a man who called when there's a man who called Galileo. So the Galileo actually he discovered he built out something, and this not he just have a very powerful tools. So this tools is the telescope. So in Chinese, the 望远镜. So the telescope can help us to observe the object very clearly. He just used the lens and to construct the use the lens and to construct all the structures to help us to understand, to help us to observe the galaxy in the skies. So here's lots of stars, or maybe here the sun, or here maybe the moon, just using the eyes. Okay, so this is really powerful tool to help us to understand the world. And for in Galileo's discovery, you find that there's a one very important thing that he find out that the satellites. So what is the satellites? So the satellite is just like the small objects will circle around the planetary. So we know until now that we know the Earth will circle around the suns, and we call this in the Earth science we will call this as the Earth is a planet, and the Venus is planet, Mars is planet, and Jupiter will be is also the planets. However, that some planets have some planets actually in outside the planets will be there's some small object, and this small object actually will be composed by the some dust, ice, or maybe the rocks. So actually he will circle around this that will circle around this the planetary. So we'll call this the satellites. And the Galileo he find that he finds something is important, that he find the Jupiter. So the Jupiter have the four satellite have the four satellites. You have the four satellites to circle around the Jupiter. So this is a really very important discovery, because in the past all the scientists didn't have the telescope, so they cannot use they only use the eyes to observe. However, the eyes actually can just observe the shape of the planetary. You cannot not follow that there's lots of the satellites, and also the Jupiter have rings, and the ring has lots of so the Jupiters, we will call this the 木星. Okay. So when this two will be there's some discoveries in the past, and also that there's a man who called Tickot, and Tickot he is a man who really likes to observe, and really like to observe the stars, the objects in the world, and also like to see in the sky. So he collects lots of the data, almost the 40 years ago. Okay, so here the Ticos have a system we call the Kepler's. So Kepler's he's showing out because that he is an assistant of the Ticos, and Ticos collect lots of data almost 40 years ago, and he finally find out that Kepler's, and Kepler is a very very good at mathematics. So he used all this data to he used all this data to collect and final to collect all the data, and finally finds out some rule. He found out some rule to follow the there's some rules in the skies, so everything is just showing out. So this is today's we want to talking about the planetary motions laws. So the first one, we have to focus on the first law of the Kepler. Okay, so the first law of the Kepler, he talking about that all the things, all the motion, the planetary in the sky, actually he just in another circles. He is a ellipse. So when this ellipse means that he will this is the focus. So this is the focus, and the sun actually is on the focus. So in this application here, we will call this the we'll call this is a really particular region. We call this is 8, and here is the B, and this is position is C, and also this is the E. Oh, sorry, this is a D. Okay, so when we here the BD, when we line some, this is here is BDs, and also here is the AC. Okay, so over here is the central of the oats. So when we from O to B's, here will be the O to B. It means that this is the we will use letters to represent the length of this OB turns will be the B's, and also we will use letters that the A small a's, that this is the AO turns. So we from BF, the BF actually will find that there is something very important properties for the ellipse is that when this point, this lines actually this another find one. So from here's to here's. So in the in the ellipse the elliptical property you find out that the BF. So the BF1 is equal to the BF prompt. Okay, so here is this is a cent, and the cent, and this length actually is equal to the AO, and AO is the 8 over here. So you will find that if the planet, if there is a planet over the A positions, here is the sums. So the A position we can use a terms that if this is, and if here is the C. Okay, over here this is the C. Okay, so we will know that the AF, we can use the form, we can represent it. AF is equal to the A plus C. And also we will know that the CF prime is equal to the A abstract C. Okay, so it's just like this. So we will call the A is the Fowlix point, and the C is the Corliss point. Okay, so this is the first law. Okay, so the first law here, we find out that all the planetary and the object will circle around the sums. So this is really the first law we've got to focus on that. And actually that in the past the scientists will use some the math to represent it, like the definitions of the E's. The E in Chinese is 离心率. Okay, so this is the definition is equal to the A C over X. So the value of the E's actually, it means that if the E is equal to the 1, it means this is a circle. So if the E is between the 1 and the zeros, it means this is the ellipse. Okay, so this is the first law we want to talking about that. And so if we have accepted these ideas that we know the sums, we know there's a planets will circle around the sum. We will use a term to represent this. The R is equal to the F plus CF over 2. So the answer is 8. Okay, so this is 8. So you will find that if you want to use the A to present, it means that A is actually a kind of a radius, but this added radius is not a circle radius. Okay, there's a name we call the 平均 average radius. Okay, 这叫平均轨道半径。Okay, so this is the first law we're talking about in the planetary motion, and it's just like this one. Okay. So here now we want to talking about the second will be. So this is second. We were talking about. So here we want to talking about the second law. Okay, so this is second law. So when we're talking, when here there's a sums, and here is the planetary is starting from the here. This is the A point, B point, C point, and D point. From A to B, so D is the TAB, and here's is the TCD. So here the variation. So the second law means that if the variation is the same, so it means that the variation T is equal to the variation CD. So if there's the time in interval is the same, we will find that the area S1 and is equal to the S2s. So this is we call the second law, or maybe we'll call the Ariel's law. It means that it will circle around, so it will be found as home. So what is the physical meaning in this mathematical formulas? It means that the distance, we will take some particular way, the particle position like this one. So this is the V2, and here is the R2. Over here is the R1, and this is the V1. So the V1, R1, the products of the R1 and V1 will equal to the R1, R2, and V2. Okay, so this is we call the very important. There's an important formula because it helps us to know an idea is that when the R1 is bigger and the V1 will smaller. When the R2 is smaller, the V2 will be bigger. So this is the very important property to help to understand the ideas of these formulas that so when the planetary will circle around the sums, so you got to apply the first law and also the second laws. Okay, so after the decades, the Kepler proposed the third laws, and I think the third laws will be the I think the third will be very important laws. So it means that when here this is the sums of in the sums in the sum in the universe, and there is the planetary will circle around the sun. We call this the planetary one, and maybe the Mercury, the Mercury ones, and this orbiter is the radius of the Mercury. And also here is the second orbiter, the third orbiter, and here is the fourth trajectory orbit. So we have the different orbits. They will have the different trajectory of the trajectory of the planetary. So it will circle around the sums. Okay, so they will circle around the sum, circle around the sum, circle around the sums. Okay, so this is really important in the third rows. So all the things actually who will follow loads, and this row is very simple. That just like the R Mercury's the cubics over the period squared of the Mercury, and also equal to the R Venus cubics over the time intervals of the Venus squared, and over also like this one. Okay, so you will find that if if all the planetary circle around the sums, and they will find that they will equal to a constant. So this is equal to a constant. So if you change this into the pictures, you change these ideas into a picture just like this one. This is the R squared and r cubed. Here is the time squared just like this one over 1 the Mercury's, Venus, Earth, Mars, and Jupiter, and so on, just like this one. So he will follow this. Then all the things will follow these lines. So this is a really important third row. So we call this the third row is about the period laws. So we have already told you that there's a 3 laws in here. So all the planetary and also the satellites, when we use the satellite to circle around the planetary, they will follow the third laws. And also if we are if there is another galaxy and there have stars and also have the planetary will circle around the stars, so everything will be fine in this, will be well used in these three laws to follow out. Okay, so until now we have already told you that there is something very important for topics when we're talking about the mechanism. and we use the gravitational force to help us to combine. We use the gravitational force to help us to combine the scientific and scientific method, and also this the Kepler's law actually using lots of data to collect all these things. So we can get some reviews that the induction laws and the deduction laws. So the induction laws and in deduction law, you can use this to fix in the Kepler's laws. Okay, and also use this into the gravitational laws to combine this together. So we know until now that science actually we can use both methods to follow up. One is the gravitational laws, and also another will be one is the gravitational force and one is the Pyrrhus, one is the Kepler's laws. Okay, so this is today's topic. We're talking about the Kepler's laws and planetary motion, and also the backgrounds of original of the planetary motion. So both of all of you got to follow up this chapter. So maybe all of you will be find out some interesting in these topics. Okay, thank you all, and we will come back soon to know the much more things in the about physics.